So the problem was this, normal distribution with mean 35K, standard deviation 7K. We want to find the bottom 3%, people, those who fall in the bottom 3%, which is this, right? 0.03 or 3%. We want to find the income level, which is this, let's call it X, income level below which someone would fall in the bottom 3% of the wage earners. Since this is a normal distribution with mean other than 0 and standard deviation other than 1 as well, we cannot find the probability using the table unless we convert it into a standard normal distribution, which we all know how to do it, right? So let's go ahead and do the standard normal distribution thing. So which is a mean of 0, standard deviation of 1. And we know how to go back and forth between these two by using the formula z is equal to x minus mu over sigma, or z is equal to x minus x bar divided by sample standard deviation s. So what we need to do, since we don't know what this x is, we can go to the standard normal distribution and consider the exact same amount of area. That means 3% or 0.03. So 0.03 or 3%. Now, what we need to do, we need to find this z value, okay? Find this z value, and once we find the z value, we can use this formula to map this z to the corresponding x in the normal distribution that we are considering. So that's the strategy. So we go from standard normal distribution, we go from normal distribution to standard normal distribution using this formula. In this case, however, we have slightly different thing here, keep in mind. So previously, what we have had the z value, okay? We have had the z value, let's say z some value a, and we found the probability that z is less than a, or we found the probability that z is greater than a. We knew z. However, in this problem, it's just the opposite. We don't know the z, but we know the probability, either this or that. In our particular example is this. Probability that someone will be at the bottom of the income or wage earners is given to be 3% or 0.03. So this area is 0.03. Now, how does it relate to the z-score? So what is the z-score associated with an area of 0.3? So in essence, we are looking for the z such that z is less than some value a, such that the area is 0.03 or probability is 0.03. In continuous random variable or continuous probability distribution case, by the way, probability and area, they are interchangeable. They mean the same thing, okay? When I say probability, I mean area. When I say area, I mean probability, because probability is defined by the area under the curve, okay? Now, this is where people are struggling. What they're doing is this. They are not being able to find out where the value is. Now, previously, you have looked at this column. Previously, you have looked at this column for z, and then for the fraction, you went along the top row. Then you found the corresponding entry in the body of the table. However, this time we don't look here. We look inside the body of the table and try to find the value that is closest to 0.03. Closest to 0.03. If you look in the table, we are looking at the z-scores table for the negative z value. Okay, so you might have question, should I look at positive z-scores or negative z-scores? If your area or probability is bigger than 0.5, you look at the positive. If it is less than 0.5, you look at the negative z-score. All right. If your probability is bigger than 0.5, you look at the positive z-score. If it is less than 0.5, you look at the negative z-scores table. So if you look at the table, you can see the value that is closest to 0.03 is 0.0301. 0.0294 is close, but 0.0301 is closer. So if I look at this item or look at this value and go along the row, I see that I am at negative 1.8, negative 1.8. And if I look at the column, I see that it is at 0.8, right? So it's going to be, 0.08. So it's going to be negative 1.88. So z value associated with an area of 0.03 is going to be negative 1.88. So let's go back now.
Mr. Hussein, I have a question.
Yeah.
When you got negative 1.88, why is it negative 1.88?
1.88. Okay, so let's go back to the table then. See here, where is it? Negative, 0.0301 right here, right? So this row gives you negative 1.8, right? And if you look at the column right here, is 0.08. The way this table works out, that you have to add these two numbers, 1.88 and 0.08.
Okay,
So,
I understand.
1.80 plus 0.08. That gives you 1.88.
All right, I understand. Thank you.
Mm-hmm. All right, we found our z to be negative 1.88. Now, what does that translate to here, x? So we could easily use the z is equal to x minus mu. Let me use this space here. Z is equal to x minus mu over sigma, right? Z is equal to x minus mu over sigma. So what is z? Negative 1.88. Negative 1.88 is equal to x minus mu. Mu is 35K. So 35,000 divided by sigma, which is 7,000. So you multiply both sides by 7,000. Okay. So if you do the math, this and this cancel out, that gives you x minus 35,000 is equal to, this comes out to be 7,000 times 1.88, 13,160 negative 13,160. Then you add 35,000. So you get 21,840. 21,840 is equal to, these two cancel out, x. So this x is 21,840. That is what it is. So if someone makes below 21,840 or 21,840, let's say, that person would be considered at the bottom 3% of the income level, or would be among the bottom 3% of the wage earners. And that's a concept you should know. So when you are working on problems, make sure that you know what is it that the problem is asking, or what is it the problem has given, because students get confused. With my last section, I saw students looking for Z when they are given probability. They were using 0.03 as the number for Z. 0.03 is not the value of the Z. 0.03 is the value of this shaded region. And there is a corresponding value for Z for this probability, which happens to be negative 1.88. And you look it up in the table. You look it up in the standard normal distribution table using the fact that probability is 0.03. So you have to look in the body of the table and look for the thing. You have to look in the body of the table and look for the corresponding Z-score. Now, the next problem is the top 3%. So I want you to work on it. Now you should have enough knowledge what income one should make in order to be considered among the top 3% of the wage earners. All right, so let's go ahead and work on it. I'll give you a couple of minutes to work on it. So we want the top 3%. So that would be to the right, top. So this is the X value that we are looking for. X is equal to, so this area is 0.03 or 3%. So you want to find out the income level above which someone would be considered among the top 3%. So the same thing we are going to do here. 0.03 or 3%. And we are looking for the corresponding Z value. So what is the Z value? That's the question I am asking. What is the Z value? Anyone found the Z value? So what is the Z value? George, you got it? How did you get it? Explain to us.
Hello.
Yes, George, go ahead.
Yeah, last time on class, you explained how the thing is symmetric, and that
Great. Yes, go ahead.
how it was 1%, and then no, I'm sorry, I forget how to explain.
I know you got the idea. Excellent, thank you.
Mhm.
George got the idea. Because of symmetry, look, normal distribution is symmetric about the mean. So left half is a mirror image of the right half. So left 3% gives you negative 1.88. So the right 3% would give you positive 1.88 for Z-score. That's one way, and easy way to find out, because you already found out. But what if you didn't know? Let's say I didn't do the first part of the problem. In that case, you don't know what is the left side. So if you didn't know what it is, how would you find it? Without symmetry. With symmetry, you can find it here. But if you didn't have the left side done first, then how do you find this one? So I want to get your feedback. How do you find this Z value of 1.88? Anybody? First of all, you're looking for this Z value. Remember, when you're looking at the standard normal distribution table, it gives you, for any particular Z value, it gives you all the area to the left, not to the right, to the left. So when you're looking for some Z value, you're actually looking for some area from that point all the way to the negative infinity, okay? So now what's going on here is this. You should not be looking for 0.03, but rather you should be looking for the area to the left of this z value, which is everything right here, all the way to negative infinity, which would be 1 minus 0.03, which is 0.97. So now you should be looking at z-scores table for an area of 0.97. Since 0.97 is bigger than 0.5, you should be looking at positive z-score, okay? Positive z-scores table. If you look it up, you'll see that the value is 1.88. Actually, let me show it to you. So for 0.97, remember, you don't look for 0.03. If you're looking for 0.03, you're looking at the left side. That is not what you're looking for. You're looking for the right side. So to find the right side, to z corresponding to the area to the right, you need to subtract that area from 100% or 1, and then take that area and find the z value from there. Is it okay? All right. Now let's bring the table back. I'm gonna erase everything here for a second. So we are gonna look at the positive z-score and 0.97. What is the closest value we can get to 0.97? 0.97, 0.96, 0.97, 06, okay. That's the closest value. This one, 0.9699. 0.9699. That's the closest value we can get. And then see, this corresponds to 1.8. And if you go up, it corresponds to 0.08. So 1.88 positive, of course. See, this is how it's calculated. This is how you should be finding the values. Okay. So now let's bring back the rest of the stuff. So z is 1.88. So the rest is easy. This z value is going to map to this x value here. So z is equal to x minus mu over sigma. Z is 1.88 is equal to x minus 35,000 mu. All of it divided by the standard deviation, which is 7,000. Then you multiply both sides by 7,000. This and this cancel out. That gives you x minus 35,000. And if you multiply these two, you're going to get 13,160. Then you add 35,000. Add 35,000. That's going to give you 48,160 is equal to x, or x is equal to 48,160. So if someone makes more than or equal to $48,160, then that person falls among the top 3% of the wage earners, top 3% of the income level. And that is what it is. Now, does it make sense to everybody? This is an important concept. You need to be quite comfortable with it.
Mr. Hussein,
Yes.
could you possibly go over again why you use one side of the chart versus the other?
You mean the positive z-score versus negative z-score?
Yeah, because I don't think I quite understand that. Like, what do you mean by it
Okay,
being...
so the probability here is what? 0.97, right?
Right.
That number is bigger than 0.5. If
Right.
it is bigger than 0.5, then you use the positive z-score table. On the other hand, let's say if your number was 0.4, which is less than 0.5, then you'd be using the negative z-scores table. Even if you don't don't use it. Don't remember this rule. As you look into the table, you'll see if you're looking for z in z of 0.4 in the negative, in the positive z-scores table, which is right here. Let me show you. Okay. If you're looking for z in the positive one, what's going to happen? You see no 0.4. We are looking for 0.4. The smallest value is 0.5 right here. Do you see? Then you'd be seeing all the numbers bigger than 0.5. Okay. So
Right.
you'll go to the other table anyway, naturally. You really can't afford to make mistake.
So when you were saying it's greater than 0.5, at the very top of that chart, you would look for numbers from 0.5 to the right.
No, if your area, so this is the area, okay, or probability. If your probability or area is greater than 0.5, you look at positive z-scores table. If it is less than 0.5, you look at the negative z-scores table.
All right, so where I'm confused at when I'm looking at the chart, the z-score table, is you have this arrow that goes right down the middle of these, like right between 0.04 and 0.05. And earlier when you were looking for 0.97, I was looking more on the left side of the chart versus the right side of the chart. And I noticed that you selected a number on the right side of the chart.
You mean the body of the chart versus the first column and the first row?
Right.
Yeah, that's the reason, because you look at the first column and first row only if you know what the z value is, okay? If you're given z, let's say z is 1.3, then you're going to look at the first column and first row on the top. And then wherever they intersect, that's where the value of t is going to be. That means probability of z less than 1.3. But in this particular problem, you are not given z. You do not know z, but rather you are looking for the z. So the problem here is that for a particular point, let's say 1, if you know what is, if z is equal to 1, if z is equal to 1, probability of z less than 1 is equal to 0.83 something, 0.83 something, I forgot, okay? Or 8413, I think, 8413. But in this particular problem, they have given you 0.8413. You just need to find this z. So the game plan is different here. In many cases, you know z, you find this. But here, you're given this, you need to find the z. That is why, and this value comes from the middle of the, or body of the table, right? So that's why you look in the inside the table or in the body of the table, and then go along the row and along the column the way I did, and find the corresponding z that would give you the value. Is it making a little bit more sense, Don, or not yet?
Not yet, but I just have to practice some, I guess.
Yeah, I think these concepts initially takes a bit of thinking, so it's not so easy. I remember my early years when I used to teach this class. I had to spend a lot of time preparing for the class because the concepts are not easy. Okay, so it takes a little bit of time. It comes to me naturally now because I have seen it 100 times probably. But you are seeing it for the first time, so no worries.
Yeah, I'll just have my spouse will help me figure it out whenever I get stuck.
Okay. Yes, that would be good if he does, because these problems. By the way, you have to teach statistics. So I don't know if he teaches statistics. So if he does, then it should be pretty easier. Otherwise, if he has to figure it out, then it will take a little bit of time for him, or anybody, as a matter of fact, who is not used, who haven't seen the concepts recently. Any other question, Don?
No, I don't have any. Thank you.
Mm-hmm. All right. Now I'm going to get you more practice on this. So let's go ahead and do this, this problem. So let's clean it up. So let's go ahead and, okay, I'm gonna switch gear a little bit. So in Dhaka, let's have you look at the slides as well. Let me get the slides. Where is the slide? Right here. Okay. It's page number 121 in the slide, lecture slide. Z-scores example 6. In Dhaka, which is the capital of Bangladesh, average income is $1,500. So mu is $1,500, and standard deviation sigma is $300. Okay. In all of these problems, I'm kind of making the assumption that we exclude, because income distribution could be very, very unequal. Okay. There could be people who are making a lot of money, and there are people who make very little. So what I'm doing, I'm kind of making the assumption we exclude extreme incomes, okay? Just for the ordinary people, exclude extreme incomes. Income technically is measured by median, I mean middle of the income. So remember that. You remember the concept of median, okay? It's measured by median. I could have used some other standard example, but I don't like to, because I like the money example. That's easier to relate to. You guys can kind of visualize it on your own, okay? And for the most part, if we take the middle part of the society, let's say, excluding top 3% and bottom 3%, the middle is pretty much, you could approximately say that it's just about bell shape, okay, or normal distribution. So this time income is normal distributed with a mean of $1,500 and standard deviation of $300. And based on this information, I want you to answer the following questions. Number one, probability that a randomly selected person in Dhaka makes less than $1,000. Number two, find the probability that a randomly selected person in Dhaka makes more than $1,800. Number three, the probability that a randomly selected person in Dhaka makes between 1,000 and 1,800. Please note that these numbers, I have you go over these first and then do this. So there must be some relation between the two. The number four, probability that someone makes exactly $1,500. So please try working on these problems. I'll give you a few minutes to work on, and then I'm gonna do these problems. And look at the slides and have the table ready as well, okay? Look at the slides, lecture slides, and have the table ready. And just answer the first two, okay? Answer the first two. Then you should be able to answer the rest easily. So go ahead and work on it. Few minutes, please. Okay, guys. What about number one? What is it you got? Number one. Anybody has any comments on number one?
Is it negative 384?
Negative 384. Hopefully you don't make negative money.
Just taking a stab at it.
Negative 384. The probability cannot be negative also. I don't know which one you may mean. All right. First of all, probability that someone makes less than $1,000. So 1,500 is right here in the middle. So 1,000 would be probably somewhere here, 1,000. We want to find the probability that someone makes less than 1,000. So that is going to be to the left. Less means to the left, more means to the right. Since this is not a standard normal distribution, we need to convert it into standard normal distribution and then find the corresponding z-score. So mean of 0 for standard normal distribution and standard deviation 1. So normal distribution, standard normal distribution. So z would be somewhere here, right? So then this area, these two shaded regions are proportionately equal. Now, we need to find the z value, which is easy. Z is equal to x minus mu over sigma, which is 1000 minus 1500 divided by 300. That is going to give you z is equal to negative 500 over 300, which is negative 5 over 3, or approximately negative 1.67. It's negative 1.66 repeating. So it's negative 1.67. So, oops. Z is equal to negative 1.67. So probability that X is, so this point maps to this, or vice versa. Probability that X is less than 1000 is the same as the probability that Z is less than negative 1.66. I mean 67. Right? Now, this is the area to the left. We can easily find it from the standard normal distribution table. So let's go ahead and look at it and clean it up for a second. Z is negative 1.67, negative 1.67. So look, negative 1.6, oops. Negative 1.6 and 7 is gonna be right here. So this is the value, right? Where is it? Right here. That gives you negative 1.6 and 7 is over there, right? So 0.0475. So if I get rid of this stuff, I get 0.0475, which by the way is 4.75%. So there's a 4.75% chance that somebody randomly selected off the street would make $1,000 or less. Now we do the same thing for the other side, okay? So probability that someone makes more than $1,800. So 1,800 would be somewhere here, right? So more than 1,800 means we are talking about the area to the right. More than 1,800 means area to the right. So we need to convert 1,800 to the corresponding Z value, right? Here, so Z. So, and that is gonna be this region we are talking about. So Z is gonna be equal to X minus mu over sigma. X is 1,800 minus mu is 1,500 divided by sigma is 300. If you do the math, 300 over 300 is just 1. So Z is equal to 1. So this is equal to 1. So this 1 maps to this 1,800. So probability of X is greater than 1,800 is the same as probability of Z is greater than 1. Now we are looking for the area to the right. Remember, if you look it up in the table, for Z is equal to 1, it will not give you the area to the right, but rather it will give you all the area to the left, all the way to negative infinity. And you don't want that, but you rather want the right. You know, all the area under the curve is 100% or 1, correct? 100% or 1. So from 1, if you subtract the area to the left, is going to give you the area to the right. That is to say, probability of Z greater than 1 is the same as 1 minus the probability of Z less than 1. Observe, this is greater than and this is less than. So that is going to give you 1 minus the probability of Z less than 1. If you look it up on the table, you'll get Z is equal to 0.8413. Okay, so that is going to give you 0.1587, or there is a 15.87% chance that someone will make more than $1,800. Okay, someone will make more than $1,800. Any question on this, anybody so far? So folks, I'm spending a lot of time on this material. I have already covered it. I'm going over it again. The reason is that this is something you need to be solid on, okay? So please make sure to pay attention, do the online homework, and make sure to ask questions in the class if you are not clear on anything. Don't be shy and kind of hiding, all right? The next is this one. Probability that someone makes between 1,000 and 1,800. So this time I actually want this middle region. That's it. This middle region, which is equivalent to this region. Now, if we look for, so this is the same as probability of negative 1.67 is less than Z is less than 1, because we found for 1,000 Z score was negative 1.6, right? For 1,000 Z score was negative 1.6. For 1,800 Z score was 1, right? So 1,800 Z score 1. This is what it is translating to in the standard normal distribution. Now, if you look it up on the table, for Z is equal to 1, you're going to get all the area to the left of this point, as I said before, everything. But I don't want this portion. But that portion or that left shaded region is associated with this Z score, negative 1.66. So if I subtract the left shaded region from the Z is equal to 1 score, then I'm going to get the middle portion. All right. So that's to say, that is to say, probability of Z less than 1 minus the probability of Z less than negative 1.67. Now, we found these values before. Z less than 1 is 0.8413 minus Z less than 1.67. Probability of Z less than 1.67 is 0.0475, 0.0475. If you do the subtraction, you get 0.8413 minus 0.0475. That is going to be 0.7938. So 0.7938 or 79.38% chance that someone will make what? Between 1,000 and 1,800. Someone will make between 1,000 and 1,800. There is a 79.38% chance. And the last but not least is this. What is the probability that someone makes exactly $1,500? What is that probability? What is the probability that someone makes exactly 1,500? Okay, so at least someone remember? Is 0. Because in the continuous case, probability of a single point is 0. Okay. Why is it 0? Because you have a height, right? So you have a height, right? This, but the width is 0 for a single point. Therefore, 0 times a fixed number is 0. Okay, so the area is 0. That means the probability is 0. It's a consequence of the definition of probability in the continuous case, that the probability of a single point is 0. And that should take care of everything. That should take care of all the things involving this problem. This kind of covers the whole gamut of things that you need to know in order to find the probabilities associated with normal distribution. And the other problem or other type of problem is the opposite one, where you are given the area and you want to find the corresponding probability. So let me go ahead and jump into the next type of problems. Okay. So that is gonna be the smartphone problem. Is going to be slide number 123. So everybody please go to slide number 123. Again, I want you to try this problem first, okay? I'd like you to try this problem first, and then I'm gonna go ahead and do it. So smartphones, they have a life expectancy, mu is equal to 36 months with a standard deviation of 6 months, all right? Now, you want to buy an insurance policy is going to be long enough so that it only doesn't cover 2% of the times. But for a typical phone, it would cover the remaining 98% of the times. So how long should the insurance policy be for? So that means how long do you have to buy the insurance policy for so that you can go ahead and be sure that there is a 2% chance that your phone will not be fixed if it breaks down because your insurance period has expired. So go ahead and work on this problem a few minutes, and then I'll go ahead and do it for you. Okay, guys, I see some numbers on the chat. They're incorrect. Someone is saying, George is saying 23.7 or 48.3. Okay, so that means you are not clear on one point. That's why you're getting two answers. You're not sure what you're looking for. Yeah, the answer is 48.3 or 48.6, something like that. So let me work on the problem, what it is. So you have smartphones that have bell-shaped curve with their life expectancy is normally distributed, and mean is 36, and standard deviation is 6. So the problem has a kind of a twist. You have to think about it a little bit. You want to buy an insurance policy so that 2% of the times it will not be covered. Insurance policy has to be long enough so that 2% chance that it will not be covered. So that means your phone has to survive and be among the top 2%, be among the top 2% or 0.02. And only in that case, it will not be covered. That means if you buy insurance policy up to this point in time, let's call it X, you will be covered. But if the phone lasts beyond this point, then your insurance policy would have expired and it will not be covered. And the chances of the phone lasting beyond the point X is 2% because this point X beyond that is the top 2% of the phones that survived. So now this is the key understanding to the problem. Next, what you need to do is draw the standard normal distribution curve, which has a mean of 0 and standard deviation of 1. So again, you look it up, you do the top 2% or 0.02, which is 2%, right? Now, you need to look it up in the table. Associated with this point, this Z, associated with an area of 0.02, which is the shaded region, there will be a Z value. That's what you're looking for. Okay, George, you're looking for the Z value. You're given the probability or given the area. You're given the probability. So what you're looking for, we are looking for some value of Z, let's call it A, such that probability of Z less than A is some number. Oh, actually, to be more precise, I don't want to make your life complicated than what it should be. Technically, we are looking for an A such that probability of Z greater than A is 0.02. That's what it is. We are looking for this particular Z such that probability that Z is greater than this point A is 0.02. Now, this is a scenario where you should not be looking for 0.02 area because this area is to the right. So in essence, you should be looking for area of 1 minus 0.02, which is 0.98. So on the standard normal distribution table, you should look for an area of 0.98. That is everything to the left of this particular point. Now, by mistake, if you look for 0.02, then you are not getting this Z value, you are getting the Z on the other side. But if you are careful, you could think, oh yeah, you made a mistake, and then you could just flip it. Then you'd get the right answer. Now, let's bring in the table. So I'm looking for 0.98, right? So 0.98, so this is the negative. So Don, this is where you may want to pay closer attention. 0.98, okay? 0.98. That number is bigger than 0.5. So that means you should be looking at positive z-scores table, not the negative z-scores table, which is this one. So we're going to look at positive z-scores table and try to find the value that is closest to 0.98. So which one is closest to 0.98, 9850, 9808, 9798, 9803. So 9798, that's the closest value. Okay. 97, where is it? I lost it. 9798 is the closest value to 0.98. This one is actually a little bit further. So if we look at this row is 2, If we look at this column, it's 0.05. So your Z value should be 2.05. Let's bring back the screen. So Z is 2.05. Okay. Now, this point corresponds to this point, okay, in terms of mapping. So Z is equal to X minus mu over sigma. Now Z is 2.05, so 2.05 is equal to X is the number we are looking for, mu is 36, right, mean, and standard deviation is 6 months, so 6. So that's gonna give you, now you want to multiply both sides by 6, that's gonna give you 2.05 times 6 is equal to X minus 36, X minus 36. Now 2.05 times 6 is 12.3 is equal to X minus 36. Then you add 36 to both sides. That's gonna give you 48.3 on the left and on the right just X. So your X is equal to 48.3 months or approximately 4 years. So you want to buy insurance for approximately 4 years, okay? You want to buy insurance for approximately 4 years so that your phone is covered. And if you buy insurance for 4 years, you have about 2% chance that your phone will outlast 4 years and the insurance will not cover your phone. And this is the reason when you buy an iPhone or any of the other phones like Samsung phones or whatever, Google phones, they sell you insurance for 1 or 2 years. I know for Apple, it's maximum 2 years. They will not cover anything beyond 2 years. And of course, in the first 2 years, you can expect nothing to be wrong pretty much with the phone. If anything happens to the phone, that will be after the first 2 years. So this is very sweet premium that they are collecting, and it's not cheap. And even after that, if you purchase the insurance, what happens is that it doesn't mean that if the phone goes bad, you're gonna get the phone free. I think, still have to pay $100.
Yeah, my
So,
spouse lost his phone at a concert this weekend and he had to pay $180.
yuck. 180?
Yeah, 180, and they even sent him a refurbished phone. It wasn't even new. I was like, what?
Who was it? Is it Apple or Google?
It was an Apple phone. It was an iPhone.
Oh my goodness. Why 180 though? It's supposed to be $100.
I don't know. I think it was because we were still, we've only had the plan for like 6 months. So I think that's probably why.
Yeah, like I told you guys when we were doing expected value problems. Do you remember? Expected value problems. The odds are always against you. The chances of you winning against the house is not there. That means your expected return or expected value for gambling is negative, meaning you're always going to lose money. The same with insurance. And Apple or Google or any of the insurance providers, when they do the calculation, it's a big business and they make good money off of it. Very good money. I told you, insurance is one of the biggest drivers of economy because so many types of insurance, car insurance, home insurance, life insurance, I don't know, whatever kind of insurance, many other types of insurance, right? Is the biggest, health insurance. I forgot to talk about the biggest one, health insurance. Trillions of dollars flowing into the economy in the form of insurance premium. Yes.
A majority of my money goes to insurance, like health insurance, home insurance, earthquake insurance, auto insurance. It's insane.
Yep. Yeah, it's true. You're right, absolutely. All right, good. Any question, anybody on this problem? No question? Okay, now I'm gonna give you another problem, which is this one. Page number 124. So let's say the GPA for a school, let's say at Hartnell, GPA, mean GPA for students is 3.25, 3.2, and standard deviation sigma is 0.25, okay? Now, the school has decided to give scholarship to top 3% of the students. Top 3% of the students are gonna be eligible to apply for some scholarship, let's say. Top 3% are eligible to apply for some scholarship that college is offering. Now, the question is, what should be your GPA, minimum GPA, in order to be able to apply for this scholarship? Okay, there should be a cutoff GPA below which you cannot apply. If you're above that GPA, you will be able to apply for the scholarship. And assume that GPA is normally distributed with mean of 3.2 and standard deviation of 2.5. GPA is normally distributed with mean of 3.2, standard deviation 0.25. So go ahead. If you understood the last problem, you should have no difficulties doing this problem. Structurally, exactly the same. Concept-wise, exactly the same. You just have different sets of numbers. All right. Go ahead and work on it for a few minutes, please. All right, guys. Anybody got the final answer? What is the GPA that one should have in order to be eligible for this scholarship? Okay, Danny, at least one person got it. Let's work on the problem. Average is 3.2 and standard deviation is 0.25. Okay. So you want the GPA that's gonna be the 3% boundary breaker, okay, or X value. So that means this area, is it 3%? Yeah, top 3%, 0.03 or 3%, okay, this area. You want such an X value, that means such a GPA, so that above that, a student will be considered among the top 3%. And then if a student has that GPA or above, then he or she will be eligible for the scholarship. That means the person could apply for it. Mean 0, standard deviation 1, top 3% here. This is your Z, and we want this Z, and this is going to correspond to this X. And this is also 0.3 or 3%, or the top 3%. Now, what is this Z value? This Z value is something you need to find. You find it from the standard normal distribution table. Now, remember, we are looking for the area to the right. The probability of Z greater than some value A such that the probability is 0.03. Probability of Z greater than some value A such that area is, or probability is 0.03. Now, you don't look for area of 0.03 because it is to the right. Remember, standard normal distribution table gives you all the area to the left for a particular z value all the way up to negative infinity. It does not give you the area to the right. To find the area to the right, to find the area to the left, you just subtract it from the area to the right. So 1, all the area under the curve is 100% or 1, right? So if you subtract from 1.03, you're going to get 0.97. So you're looking for 0.97. Again, down here, 0.97 is greater than 0.5, right? Which
Yeah,
table
I got
should
the
be-
answer right on this one.
Okay, so which table should I be looking at, Don?
You should be looking at the positive table.
Exactly. If my area under consideration were, let's say, 0.3, which would be less than 0.5, then which table should you be looking at? Point 0.3 is less than half or 0.5. Which table should you look at? Positive or negative?
Negative.
Negative z-score table. But our value is 0.97, so we are going to look at the positive z-score table. If you look it up, I can do it again. I'd rather do it again because people really need to get a feel for this stuff. Okay, clear? 0.97. So let's see, what is the closest value to 0.97? 0.9686, 0.9699. It probably won't get any closer than this, 0.9699, which is 0.97. Let's look at that's 1.8, 0.08. So 1.8 is the same as 1.80 plus 0.08, which is going to give you 1.88. So your z value is 1.88. So let's bring back all of that. So z is 1.88. So this z value is 1.88. Z is equal to 1.88. Now this corresponds to the x value right here, right? So z is equal to x minus mu over sigma. My z is 1.88, right? 1.88 is equal to x is the value I am looking for, minus mu is 3.2, right? 3.2 divided by sigma is 0.25. Now I multiply both sides by 0.25 to simplify this, 0.25. The left side is, I think, 0.47. Is equal to this cancel out, x minus 3.2 plus 3.2. If you add this, you get 3.67 is equal to x. So x is 3.67. 3.67. Okay. So if someone's GPA is 3.67 or above, then that person would be, or that student would be among the top 3% of the school population, or among top 3% of the students in terms of the GPA. And then he or she would be eligible to apply for the scholarship. That kind of concludes everything that I wanted to talk about for the materials at hand. Next, we are going to start talking about central limit theorem, or CLT. But before that, we have to talk about sampling distribution. Okay, sampling distribution, not standard deviation, sampling distribution. Sampling distribution would naturally lead to central limit theorem. Any question, anybody?
No, I don't have any.
Okay, great. I have put the central limit theorem homework online, even though I have not covered the materials. But if you'd like, you can just browse through the reading materials and try to do the problems. You should be able to. But I'll be covering the materials on Monday. all right, the central limit theorem and the sampling distribution. And that's gonna be all for the normal distribution and standard normal distribution, finding areas, finding z-scores, and going back and forth between any normal distribution and standard normal distribution, okay? This stuff should be very solid. I would strongly recommend that you watch this video multiple times if needed in order to make sure that you are absolutely clear on these concepts, because the rest of the semester is based on these concepts, okay? Normal distribution is the most important distribution in all of statistics, okay? So you need a solid understanding of normal distribution. One last time, any question, anybody?
Got a question.
No
Is
question?
there any
Okay.
examples in the slides that you didn't go through so I could do them like later? Like just to try myself?
Look at the course materials, and also in the slides, yes, there are a couple of examples that I didn't go through.
Oh, okay.
Okay, I think it's a normal distribution example 6, 7, 8, 9. Those are the ones. They're exactly the same type of thing. So you can go ahead and work on those. All right, that's all, folks. Thank you so very much. You have a wonderful rest of the week and weekend. Stay safe and stay healthy. Wear mask and wash hands. All right, take care.
Thank you.
Thank you.